Welcome back to this last section on the introduction to human biology, where we are talking about the biology of life. And in this part, we're going to learn about science and the scientific method. So when we're talking about the scientific method, this is how scientists use to gather information and come up with and answer questions about science. And a lot of students think that basically you just create a question or create an experiment. Um, and basically that's kind of going at it backwards. What you have to do first is do some background research. You have to learn about a topic. And when you learn about a topic, then you start asking yourself questions like, what if, or I wonder what would happen when X, Y, and Z. And based on learning and your education, that's when you decide, like, how about let's try something and you construct a hypothesis. If we do this, what is going to happen? And you come up with a hypothesis that I think this is what would happen if we did X, Y, and Z. And you test it with an experiment. And you come up with the results and you write down exactly what you see. The results of an experiment are things that are measurable, things that you can see, you can calculate. They are not conclusions. Okay, based on your results, you will later come to conclusions. So a classic example of an experiment would be, for instance, if a flashlight doesn't work, you would do some research about how flashlights work, and your hypothesis would be that the battery is dead. There is no energy source. And so your experiment would be to change the battery of this flashlight. And so you would find the correct size battery and you would change both batteries, and your experiment would be then to turn it on, and the results would be whether or not there is light. And if there is light, then your hypothesis would be true and you would report the results. But if there's no light, then your hypothesis is false and you would have to think again. So you have to go back to your background research and think, what were the other options? What else could lead to the malfunctioning of a flashlight? And one of the other things that you would come up with would be, well, maybe the bulb is broken. And so your second option would be to change the bulb. Now you would leave good batteries in there, because now you know you have functioning batteries. So you would change the light bulb. And if your bulb works at this point in time, then you know the problem was the bulb. And so that's an example of how the scientific method would work. And you would report the results. So when we are doing science experiments, we have very controlled studies in that we only change one variable in experiment at a time. If on that flashlight experiment, we had changed both the batteries and the light bulb at the same time, we would not have known what the problem was. So that would not have been a good experiment. So if you are looking, for instance, a new treatment for a disease, you would have to test the new treatment against the standard treatment to see if there were any changes. Or if there was no standard treatment for the disease, you would have to test the new treatment versus a placebo pill. So people would think they were getting a treatment. They just would not be getting any treatment, but they would think they were getting a treatment. And every time you do this type of a study, you need a control group. If, for instance, you are putting fertilizer or spraying fertilizer on plants, you are adding a certain amount of volume of liquid to those plants. And so to your control group, you still need to add the volume of liquid just without the fertilizer so that the two groups would be otherwise identical. And they still would need to have the same air exposure, the same wind exposure, the same light exposure. Everything else would need to be identical. And when we do controlled studies, we can have blind studies or we can have double blind studies. The blind studies are the ones where the participants don't know if they are taking, for instance, the placebo or the traditional treatment or the new study treatment. And the reason for that is you don't want the experimental participants to know, because they will give you the results that they want or they expect. So if they think the new treatment is better, they will tell you better results. If they think they're going to get more side effects with the new treatment, they will tell you more side effects. If they don't think the new treatment will work, then they will be telling you it's not working. A double-blind study means that not only would the experimental people not know which treatment they're getting, but the person giving the pills doesn't know which pill they're getting. They don't know if they're giving this patient the new treatment, the old treatment, or the placebo. So there is no bias whatsoever on their part as well. And those are the best study because there's no implicit bias on anybody's part. So when we look at the study, we identify what the different variables are. The independent variable is what it is you are changing. For instance, the statement is, if I add this, if I do this, okay? That if phrase, that's the independent variable. So it's, if I give this medicine, then you will have that. If I give this fertilizer, then the plant will do this. The then is the dependent variable. This is dependent on the if statement. So in your experiment, you always have an independent variable and a dependent variable. So an example of that is a cell phone bill. If you're active on social media and you don't have an unlimited plan, if I use a lot of social media and I'm online a lot, then my cellular bill will go up. Not so true anymore, but 10 years ago was very much true. Okay. If I give fertilizer 3 times a week to this plant, then the number of leaves on the plant will go up, or then the number of inches the plant will grow in a month will be increased, or then the number of flowers in the plant will be increased. The dependent variable, remember, it's something that you can count. It is something that is measurable. It's something that is going to be changed. Don't just say, then the plant is better, because that's not measurable. So here's a quick thing. There's a couple of different experiments. For each of them, identify the little components that I wrote at the left. So stop the video, read the little 2 different cute little experiments. They're not very difficult. Just work through it once or twice, and then I think you'll understand the process. And then continue on with the video. So now I want to talk about when we have information that is scientific information and how valid it is. There is a lot of useful knowledge in science, but when we look at this useful knowledge, only about 10% of it is really publishable knowledge in scientific journals. And these are examples of good scientific journals. I have put about 4 medical journals here because this is what I'm used to. JAMA, Mayo Clinic Proceedings are American medical ones. The Lancet is a British medical journal. Journal of Trauma is one that I really like. It's a surgical journal. Science and Nature, those are for regular scientists. Scientific American is one in much more layman's language that pretty much anybody can read. Is awesome. Now with the internet, there's a plethora of online journals that don't have quite the prestige, but allow a lot more people to publish rather than perish. But these basically are like the gold standard of scientific journals. And here's what scientific journals have in common. They are considered primary sources. They are the gold standard. They have the most current information. They're published monthly or quarterly. All the authors get identified. The authors have no conflicts of interest. They're not taking any special interest money. They're not being paid for by big pharma or little pharma or by any scientific communities. They cite all their references. They've done research. All the details are included. All of their data, all of their raw data is included. They include photos. Their study, when it's submitted to the journal, is then sent off to peers who are expert in that field to be peer reviewed. And sometimes those peers will then send it to another group to try to replicate it if they are concerned about it, or to send it to other groups to get feedback or to compare it with previous studies. And so these are unbiased sources. And what this allows, it allows the willingness to change our opinions with new evidence. And that's what science is. If you think about it, hundreds of years ago, we thought the Earth was the center of our solar system. And with science, we learned that it was the sun. Okay. And over time, we have made many modifications to what we think as far as what is true science. And this is different than pseudoscience, which I'll talk about in a moment. So when we look at a journal article, there's many parts to it. The first part is the abstract, which basically is about 200 words, which basically gives a synopsis. It tells you the gist without any of the meatiness. It tells you the whole point of this. In the article itself, it gives you the background information. What is the current status of this topic? What's the current thinking of it? Then it tells you what methodology was used and why that methodology was chosen and why that was the appropriate methodology. Then the next part, the important part that gets nitpicked, is here was the data that we collected. Oftentimes it's table with raw data and numbers, and that is like really hard to look at. And so the results often then are changed to different types of graphs, which I'll show you shortly. And I'll come back to this table in a minute. This is all different than anecdotes and pseudoscience. Anecdotes is where somebody says, well, my aunt, she had pancreatic cancer and she drank coffee every single day and it cured her of her cancer. Okay, that's their narrative. That's a story about one person. That is not a scientific article. Where's the proof that she had pancreatic cancer? And where's the proof that the cancer killed her? That the coffee cured her. Okay, that is just a story. We have no idea if she had the cancer or not had the cancer. Pseudoscience is anything that's falsely presented, and there's a lot of pseudoscience out there that patients with cancer are trying to hang their hats on. And these are people that say they have the cure for it. We can cure all kinds of skin cancer. We can cure all kinds of lung cancer. You don't like your side effects? We've got treatments that give you no side effects, okay? They're not willing to share their treatments with your doctors for your doctors to look at them because there's no scientific basis. And basically, you're just going to be paying them a bunch of money. And once again, it's all anecdotal evidence. And it's really sad when people fall for it. It's snake medicine. It's going back to buying, bottles of whatever being sold as cures. Okay, so when you look at scientific data in a table, getting back to that, each column has a separate entry where it's giving the very specific measurable data. And there's units for everything, and every table has a title so you know exactly what was being measured. Okay, and then because tables are hard to read, most of the time the data will be changed into some kind of a graph to give you a visual representation, whether it's a bar graph, a pie graph, or a line graph. And this is because it's much easier to see patterns or trends. You can look at it a lot faster. Of course, once again, we're still going to have titles and we're still going to have units. Everything is going to be labeled. It's the same stuff, it's just a visual representation. There still are units. So that's all data. Those are results. Those are not conclusions. After that, their statistics are done on the data. Standard errors are done, standard deviations, and some type of statistical significance is drawn, whether it's a p-value, which most students know about, or other types of statistical data, depending on what type of study you're being done. Following this, there's a discussion is like, does this fall into all the trends for this sort of stuff? Is this an outlier compared to previous studies? Did most of the data follow one trend? Only, for instance, females of childbearing age of Asian background were outliers, and here's why we think they were. There was a discussion of the data. And then finally, there is a conclusion. And so the conclusion is trying to wrap it all up and give some sort of significance to it. And not only that, saying, here's where I think we should go next, or what further studies should do. Should we repeat the study? If we repeat the studies, here's what we would like to do differently. Or here's what kind of tweaks we should make to this study. Okay, so those are scientific studies. And based on that, after we have a whole lot of scientific experiments that show the same thing over and over and over and over and over and over again, and we keep on proving the same thing over a prolonged period of time, then we will say that's a scientific theory. In other words, we think this really is the truth. And a scientific theory basically is telling us how nature is organized. So the fact that we say the sun is the center of our current solar system, that's a scientific theory. Yes, we give it to you in the textbook as the truth, but in reality, it's scientific theory. Just like we used to say, the atom was only composed of three things: the proton, the neutron, and the electron. We kind of said that was dogma, that was scientific theory. Now we know there's a whole lot more in there than that. Okay, so we are open to change. That's science. And here's one of this coolest thing: Edwin Hubble, the Hubble telescope out there circling the earth. He said more than 75 years ago that man, with just his senses, sight, hearing, vision, taste, touch, all the senses we're going to learn about, we explore the universe around us, and we call this fantastic adventure science. So with that, I hope you're excited to learn and explore all about the human body this semester. Okay, so here's a short little thing where you can pull it together if you want to stop and look at it. This is a scientific study of life. And with that, we are done. And the core ideas, instead of putting them here, I have typed them up and put them for you in the Canvas. And I'll do that for this first section of the course. So once again, thank you for all your studying, and don't forget to be using those study techniques. Please do them within 48 hours of watching the videos. to reinforce these concepts, because it is the repetition that's going to help you create those long-term memory connections that you're going to need to be successful on your quizzes and your tests. And I will see you soon with the second chapter, or the second episode, which is going to be about the chemistry of life. Have a great day. Bye.